Hello everybody, and what is bothering me the last couple of years that cryptocurrencies are in immense danger. And it's not because the quantum computers will crack them, they will, but there is a different reason. And also, the major players like Bitcoin and Ethereum, they do have a roadmap how to fight against this post-quantum threat and protect their data with the new novel algorithms. But there is a different issue that we talk about later. But let's start with the simple things. First of all, we need to understand what is specifically in danger. And in cryptography, there is a symmetric and asymmetric cryptography. In symmetric algorithms, basically you use the one secret key, and this secret key decrypts and encrypts the messages. So you need to share that between two parties. And in asymmetric cryptography, you have a private key and public key. You can encrypt with the private key some message, and it potentially can be decrypted with public key, and vice versa. You can use public key to encrypt the data. Also, with the private key, you can decrypt them. So it works asymmetric. That's main idea. And asymmetric cryptography is used in the handshakes and digital signatures. In the handshakes, basically, what does it mean? Our browsers need to handshake with the server to establish the encrypted connection. But problem with asymmetric encryption, it's quite slow. But symmetric is very fast. But you need to share the key safely. And for that reason, asymmetric cryptography is awesome. So it used just to share the keys. This is handshake. And the digital signatures, that's also possible to use the asymmetric cryptography to take something, sign it with your private key, and use the public key accessible by anyone to verify this data is signed by you. So you own the private key, you hold it. That's main idea. And we have plenty of this type of algorithms like RSA, Ecliptic, Curve, ECC. Also, what do we have? We have Diffie-Hellman and DSA, the digital signatures algorithm. And in 1994, Peter Shor invented the Shor algorithm, and sufficiently powered quantum computer can crack any of them almost instantly. So our asymmetric algorithms in immense danger. They can be cracked very fast, thanks to Peter Shor and inventing this brilliant algorithm. So yeah, with all of this Diffie-Hellman, ECC, DSA, digital signatures, and Ecliptic curve, bye-bye. Shor says them bye-bye. And yeah, but you will tell me, well, but with the symmetric algorithms, and this is ESA 128, 256, we are safe, isn't it? Nah, not so easy. There is another guy, the Love Glover. And the Love Glover, probably inspired by the Peter Shor and his algorithm, and he thought and invented the Glover's algorithm in 1996. And this algorithm, it's not can specifically crack, but it can halve the security. So in IS 128, using the Glover's algorithm, it halves the security, and it will be not 128 bits, it will be 64 bits. And 64 bits, considering, is not post-quantum proven. I mean, it's crackable. But IES 256, even with the applied Glover algorithm on top, it's not crackable. It halves the security, yes, and the key is 128 from AES 256. Applied Glover algorithm, it becomes AES 128, and it's still not crackable. So in this case, it's pretty secure. Glover algorithm, the Shor's algorithm, they were considering like theory because you need a lot of computational power, but with the post-quantum, they're all of this available. And there is a paper by Google that scares a lot of people like, yeah, it's possible to crack Bitcoin by 9 minutes. How does it apply it, right? Let's try to talk a bit about cryptocurrencies to understand how it's possible. So Google warned us about cracking Bitcoin. How does it work? Very simple. In the Bitcoin, your wallet address is your public key, and private key is stored secretly, and your private key is used to sign your transactions, and public key is verifying your transactions on the Bitcoin blockchain. That's very simplistic how it works. And Bitcoin is using ESDSA. It's a ecliptic curve digital signature algorithm. And it's crackable. How you know, if you apply the Shor's algorithm on quantum computer, it's really easily crackable, almost instantly on a powerful quantum computer. Probably now is available by Microsoft, IBM, maybe Google. And if they really want, they can do that, but it's not available for everyone. So it's a bit complicated. You need to have a lot of capital to do that. Ethereum also uses ecliptic curve algorithm to sign the transactions, but it gets more complicated because there is a layer 2 networks and layer 1 networks. There are 3 big points: wallet address. It uses ESDSA algorithm to sign the transactions. The second one is used by the validators, the BLS algorithm. It's a shortened from the names. And the BLS is used to collect all of the signatures from the validators who is signing the block. Instead of having a hugely long chain of signatures, it's used the BLS algorithm to have only one signature 48 bytes long, and you can use the signature to verify that everybody signed it, every validators in the world sign it. A second one is used the KZG. KZG is also shortening of the names who invented this algorithm, and this used between layer 2 and layer 1. Let's say Arbitrum is a layer 2, and it does all of the operations in the own blockchain, but synchronize every 8 minutes with the Ethereum. And the Arbitrum need somehow to send a lot of the transactions and blocks inside of the Ethereum network. And they use KZG algorithm for that. And the KZG basically instead of verifying everything inside on Ethereum, KZG applied the logic like a seal on a huge crate or container containing all of these transactions. You can do only 10 pokes, verify those 10 pokes of the data that you selected from this container with the KZG signature, and if it's correct, then it means everything inside of this block is correct. So, and KZG and BLS and ESDSA, they are susceptible and they can be cracked by the quantum computers. But luckily, Ethereum has a roadmap. They prepared the roadmap for the future. You can see here. They also do have a special website when they're explaining the all steps towards the post-quantum cryptography in foreseeable future. They prepared. Fortunately, there is a post-quantum cryptography. There is algorithms, asymmetric algorithms, which is safe to use in the post-quantum era. Invented the lattice math, and the Shor algorithm is useless against the lattice math. And also the hash-based algorithms is quite effective, and the quantum computers can't dehash it, unhash it. So it's possible to use these tools to sign things on the blockchain. And Ethereum is going there. So they do have a plan to move in the post-quantum algorithms and replace ESDSA to MLDSA, some different type of the post-quantum ciphers. But there is a problem. Post-quantum public keys and private keys are huge. Let's say with the MLKEM, the one of the asymmetric post-quantum algorithm, the public key is 761 bytes. Just for your understanding, now you do have your public key in the Ethereum blockchain, and this public key or wallet address, it's 32 bytes long, and even now it's quite difficult to remember. It's not possible to remember, let's be honest, and it's really hard to share with someone. That's why there is Ethereum domain names where you can buy the domain name for you. But what happens when you move to the 761 bytes, if I remember that correctly? What happens then? It's not possible to share. It's almost 1 kilobyte of the gibberish of some letters, so it's not possible. What can you do with that? It's a quite interesting question, and Ethereum going to use some account abstraction. And account abstraction, it's completely different topic, but they are not forcing you to update your private key and public key, but they're forcing you to use new things. If you're using the MetaMask, It happens internally. This wallet abstraction will be applied on your wallet, and then you can use the same wallet address like it was before, but your transactions will be verified differently. And we are coming closer why I think the cryptocurrencies are in immense danger, and nobody is talking about that, but it's quite important. Cryptocurrencies and blockchain are very, very complicated, and they are very complicated to understand for the average people. If you ask anyone on the street what they thinking about cryptocurrencies, they will start talking about the tangible, intangible money. Then you will probably shift to the fiat currencies and so on and so on. You start talking about some computer science, and it's very difficult because cryptocurrencies and blockchain in general, it's a mix of philosophical, financial, economical, computer science knowledge. It's everything together. It's very complex. It's very complex to understand all of these things together. Doing this shift to the post-quantum, it's even complicates everything. And it complicates even for the people who is using now the cryptocurrencies. They need to be diving in new standards and reading all of these new EIP standards, how it will be implemented in the post-quantum Ethereum, for example. And I am really curious how the modern banks or startups going to make cryptocurrencies understandable, more friendly for the average people who can use them, because it's amazing tool. It's decentralized finance, the DeFi terms for that. It's amazing thing. I think it can grow more, but it's really complex to understand for the average people. For the normal people, I mean average, I mean the people who is walking on the streets, working, I mean not people from the finance, for just normal people. It's really difficult to understand, not people who is in cryptocurrencies, businesses, and doing and programming all of this stuff. It's very complex. And I think it's an immense danger because of these complexities. And maybe the banks and other things and other companies will be afraid to use and build something with the blockchain, even understanding it's nice tools, but understanding it's will be really difficult to explain for the normal people, to attract more people in the blockchain, how to achieve it. And in my opinion, that's a most complex topic in the blockchain ecosystem. Tell me, what do you think about it? Just my thoughts. I decided to record this video to share my opinion about it. Drop your comments below. Tell me, what do you think about it? I'm very, very curious. See you next time.